Now we go to the next question. The decreasing order of leaving ability among the various, when you look at it, excepting this, all the others are nucleophiles. This is also a good leaving group because this is attached to an alcohol. Maybe we'll take it up a few minutes later. All the other groups are all, as we look at it, they are all good leaving groups. They are all nucleophiles. So the presence of these groups is important in nucleophilic substitution reactions. Most of them are halides. 4 of them, when you look at them, are halides, excepting these two. One is OTS and the other one is OH2 plus. Now, when we consider the nucleophilic substitution reaction, particularly the SN2 type, which is a concerted process. A concerted process is one where a bond making and a bond breaking are occurring at the same time. Therefore, the leaving ability of a particular group, because a stronger nucleophile replaces a weaker nucleophile. That is the concept in an SN2 reaction. Therefore, when you look at all these groups, what is being asked is arrange them in the order of decreasing order of the leaving ability. So one is the best leaving group must come first and the most poor leaving group must come last. Actually, this question is given in the form of a multiple choice question, but in order to save some time, we are just putting this and coming straight away to discuss the answer for these questions. Among these various groups, these 4 are halides and these 2 are groups that are attached to alcohol. The important point to be remembered in this connection is, normally when we have an alcohol, assuming it is ROH, whatever be the R, it may be an alkyl group or aryl group or whatever be the group, this will be OH, whenever it contains an OH. Of course, when it is directly attached in aromatic ring, it is known as a phenol. So when it is attached to a CH2, maybe we can even write it as RCH2OH or some other OH. So OH is a very poor leaving group. The leaving ability of OH is very poor. But in order to make it as a good leaving group, OH is either converted to OTS, which means tosyl group. This is actually the tosyl group. Sulfonyl group C6H5, this group OTS is a simplified form of para-toluene sulfonyl group. This is toluene CH3 SO2 OTS. I'm sorry, SO2O minus. This is actually known as the tosyl group, which is the OTS is a simplified form of this group. What is the purpose of converting the alcohol OH to OTS? This H alone is being removed and this is being substituted by means of this. Means this is a very good leaving group. Among the various groups, this is an excellent leaving group. This is the exact total contrast to an OH group, which is a very poor leaving group. Therefore, this is converted to OTS. So among the various groups, the best leaving group is OTS. So we write it in that order. OTS minus is a best leaving group. The next one is we have the OH2. But other than that, I minus is a better leaving group, or among the halides, I minus is the best leaving group for this. Then subsequently, Br minus is a good leaving group. After that, chlorine is also a good leaving group. Then only comes the OH2 plus. How do you get the OH2 plus? The alcohol is being protonated with an acid, with a protonic acid. OH becomes OH2. On account of H being introduced, H plus being introduced, OH becomes OH2 plus. So in order to make a poor leaving group, which is OH, to a good leaving group, which is OH2 plus, OH2 plus is also a good leaving group, and the last in the series among them is fluoride. So the correct decreasing order, I have not put this order here, the correct decreasing order is OTS is the best leaving group and fluoride is a poor leaving group, and in between come the bromide and chloride, and this is the correct decreasing order. The order can be arranged way or in the decreasing way depending upon the type of question asked. This is one of the possible questions that can be asked in the exams by way of a multiple choice question with a single option.